it starts up, and now it should be recording. And this will be our very first video, so we'll see. If you go on there, you'll see if it works, and we'll get someone to test it. I can also make this speaker have my voice really, really loud, but that's really annoying. So it's turned on. It's actually on, and if you listen really, get really close to it, it would be on. But I don't actually turn it very loud, other than sometimes I shouldn't have done this already because sometimes I scare people. I turn it really loud, and then I go to the corner here, and then I say something. That person in that corner, sorry, Denzel, you would have been scared, but I didn't do it. Should have thought about that beforehand. You can really scare that person in the corner by turning the volume up really loud. And it doesn't go outside of this, like it doesn't transfer very far. So if I leave to go to the washroom, you don't have to worry about, oh, you didn't turn the volume off. How embarrassing. Oh, great. That's going to be on YouTube. Okay, here we go. All right, so here's our graph of g of x. It's a function, and we are asked to sketch the graph after each translation. So all we want to do is translate it 4 units up. And this is another thing that's going to happen. In addition to we've done 5 parent graphs already. X cubed, square root of x, absolute value of x, the rational graph, and x squared, or parabola. In addition to those 5, sometimes they give you a brand new one. So here g of x is a brand new graph. We don't know its equation whatsoever, but we're going to have to do transformations with it. And it says, what would it look like if you moved it 4 units to the left? Well, all we're going to do is take each of those key points, so this one here, and we're going to move it 4 units to the left. 1, 2, 3, 4. Draw that new point. Move this one 4 to the left. 1, 2, 3, 4. 4 units to the left. 1, 2, 3, 4. And play a little connect the dot. There we go. So this is this first one in blue. I'll do the second one in green. If you had to translate this graph 1 unit up, be nice if you could do that in your notes. Just trace it and then use your finger to slide it up. But that's what it would look like in the end. So those are the drawings of each of them. Now, part 2 here, some language that we get into. Okay? In terms of the function g, so when this language comes up, for the most part, students go, whoa, what does that mean? And this is an important thing to realize, that when we do questions in class, sometimes you're going to tune out to the instructions because you're going to go, I'm just going to wait for the teacher to show me how to do it so I know what it looks like. And for the most part, that works fine until you get to a quiz or a test and you get a question and it says, write the equation of the image graph in terms of the function g. And you were like, yeah, that's when in class I was like, I don't know what that means. I'm just going to wait until the teacher shows me what that means. But when you get to a quiz or a test, you don't get that opportunity, right? You put up your hand and you say, I don't know what that means. And the teacher says, yeah, that's too bad. Because you have to know what that means in order to do this question. Same thing on an exam. So when I know that there's things that are going to cause you problems, I'm going to point those out so you can pay extra attention during class. So hopefully they don't cause you those problems when you get to quizzes and tests. So it says write an equation. An equation has an equal sign. So I'm going to go y equals. And what has happened, well, I'll start with blue because that's my blue one. For the blue one, y equals, what did we do with that blue graph? We moved it 4 to the left. How does that show up in an equation? Would it be inside the function or outside of the function? It's going to be inside because it's moving things left and right. So here's our function g. That doesn't look like a g yet. Perfect. Here's our function g. And we're going to take our values inside of g, and because we moved it 4 to the left, it would be g of x plus 4. That would be the equation in terms of g. What's happened with the green one? We've taken our graph and moved it up 1. So our original graph is there, and it happens outside of our function that we would go plus 1. Now, we're going to look at the domain and range of each of these functions. Again, I'm going to color code it. I'm going to even start by looking at our domain of our first one. And for this example, I'm going to do everything, first of all, in set notation. And I'm going to keep switching in between set notation and interval notation from example to example so you get used to both of them. But for this one, I'm going to use set notation. Domain is our x values. Our x values start at -1, and they go up to 6. This is on the original domain. And our original range, the smallest value is 2, and it goes up to 5. So 2 is less than or equal to y is less than or equal to 5. So in set notation, whenever we are doing values between something and something else, then you have a double inequality with the x or y in the middle. Now, if we go to our blue graph, looking at our graph, our smallest value now is -5, and our largest value is 2. The range of our blue graph didn't change. And finally, on our green graph, our domain is still from -1 to 6, but our range is now from 3 to 6. Now in this question, when I went to figure out my domain and my range, what did I do? I looked at my graph. I looked at what my smallest value was for the blue graph and what my biggest one was, and I was able to write a domain from -5 to 2. As you get into more of these questions, sometimes they're going to say, do you understand what's happening? Do you understand? Could you answer this question if we decided to take the graph out of it? If we decided just to give you the equations and you didn't know what the graph was. If you just got the equations in terms of g, y equals g of x plus 4, and they told you the original domain was from -1 to 6, what's the domain of y equals g of x plus 4? Well, you have to say to yourself, well, what does g of x plus 4 do? It moves it 4 to the left. Can you see how the domain just got moved 4 to the left? Subtracted 4 from the 1. -1, subtracting 4 from the 6 to get 2. Does it make sense that our range didn't change in this example because nothing affected the y? Where the value of 4 was only affects the x. So you're going to get a fair number of questions that try to take away certain parts. If we took away the graph and gave you just the equations, could you still do domain and range? You would have to be given the original domain and range then, right? So because they gave us the original graph, that's how we got our domain and range. And then in the last one to see, oh, does it make sense that our range changed from between 2 and 5 to 3 and 6? Yes, because all we did was move the graph up. And notice that from the red to the green one, the domain didn't change because our x values didn't change. So what's going to happen with each of the examples that we do in class, after we've done an example, what I'm going to do is I'm going to write down questions that you can do that are in the homework on this section. And the homework happens always right after the section is done, so you can see that it starts a couple pages later on page 169. And after we did this one together, you should be able to do questions 4, 5, 6, and 7. And depending on the lesson, sometimes I'll give you time to work on that, and sometimes I'll say, you know what, it makes sense for us to keep going and do the next example, and then you'll have to do that on your own time afterwards. But right now, since we're just starting, I'd like you to start working on 4, 5, 6, and 7. Chances are I won't give you time to finish all of them, so that when I ask you to refocus back on here, because we're going to be working on example 2, then you'll have to do that refocusing. And again, while you're doing the question, don't just try to copy what I did. You want to say to yourself, do I understand why this is working? And really take the time to try and make sense of why something's happening. Some students say, before I even start 4, 5, 6, and 7, I'm going to look at this example a little bit more and say, do I really understand what's going on? And some examples, like this one, I think, at the beginning of the year, with the activity that we did already, I think most of you are probably saying this is making sense so far, which is great. But there will be some examples later on that will take you some time to really understand.